Welcome back to Philippines Uncut. I'm Buddy Kunana. Tonight's topic is the science of earthquakes, and joining us still is Director Renato Solidum of the Philippine Institute of Volcanology and Seismology, or PHIVOLS. Good evening, Director Solidum, and welcome back to our second segment on the science of earthquakes. Yes, sir. Before we stop for our pause for a break in the first segment, we showed a short video, and to try to explain to our audience how earthquakes happen. Do you have any reactions?
Well, essentially, the video showed us that the energy causing earthquake would be the motion of blocks of rocks on Earth, which we call plates. And essentially, the upper surface of the Earth, the crust and the upper mantle, would be constantly moving. And that would be the major cause of earthquake. It's not the heat of the sun that would influence us. And you also notice that in the video, near the end, buildings collapsed. And that would be a function of the energy of the earthquake released from below, the foundation of the building, whether it's soil or rock, and how the building was designed and constructed. And for us to really appreciate the strength of the earthquake, we use two terms, magnitude and the intensity.
Okay.
Magnitude is the energy of the earthquake released from below. And that energy will be scattered away from the source beneath and will have to travel through rocks.
Okay.
Rocks absorb energy, such that if the energy is released from a shallow level of the ground, like tens of kilometers, like the Nepal earthquake, roughly 10 to 11, that energy will not be diminished much because the wave only passed through a thin
10
layer.
kilometers, about 10 kilometers.
But if the earthquake of the same magnitude was sourced from 100 kilometers, then the thickness of the rock would absorb much energy, and the energy that will eventually reach the surface will be much less than the original. And what you feel at the surface, how the surface is affected, is called the intensity of the earthquake. So what is more important now is to determine the intensity of the earthquake that affected these areas, and if you're planning for an earthquake, to project if a fault can move with a certain magnitude, what will be the shaking intensity
on the surface
that the city will experience. So in many other countries, they use a 12-point intensity scale. In Japan, they use 7. In the Philippines, we use 10.
Sir, how come there are differences? Why 12, 7, and 10?
The differences arise from the condition of the countries. In the original intensity scales used by Western countries, they have descriptions that will give you an idea of the intensity. Like, for example, bent railroad tracks, collapsed chimneys. Well, we have so few railroad tracks in the Philippines that you cannot use that in many other countries, or chimneys. So therefore, we decided we have to Philippinize, translate these things into the Philippine setting, and it is better for us to use a 10-point scale. Filipinos are used to rate something in a scale of 10 or 5, right? And essentially, it is very easy to transform our intensity to the other countries. Japan uses 7 because they devised that intensity, and now they're basing the intensity on instruments. So we are moving into that also, where aside from our own qualitative description of the earthquake, we will have 300 earthquake intensity meters all over the Philippines. That will give us the numerical intensity in a scale of 10. No? So for earthquake preparedness to repeat, it is important for us to know not only the magnitude, but more importantly, the intensity. So what happened in Nepal, you saw the after effects of the earthquake. In the epicentral area, typically it's intensity 8. And at intensity 8, when you experience the earthquake, you don't feel, you cannot stand anymore.
Okay.
The first thing that you would feel would be the vertical motion up and down,
Yes, yes.
and then the horizontal motion next. And that is where you cannot really stand anymore. So you can sit down or kneel.
At what intensity is an earthquake deemed serious? Let's say?
Intensity 8 is a very destructive earthquake.
Okay,
Intensity 7, you still stand but have difficulty.
okay.
Intensity 6, you can still stand, you feel dizzy, but things would fall down from tables
Yes.
or hanging objects will swing violently. So 8 is the most important intensity where significant damage would
That's
happen.
the threshold, perhaps.
The minimum threshold is 6.
Is 6,
Yeah,
yes.
there will be minor damage, but for significant damage to occur, it's intensity 8. That's why our building code is designed such that intensity 8 to 9 earthquakes are supposed to be withstood by houses and structures.
So, okay, we're talking about the same kind of intensity that hit Nepal. Should it hit the Philippines, if structures are done or constructed properly based on the building code,
And
they
materials used are okay,
are okay.
standard.
They should be able to
Okay.
withstand.
A very good example would be the 1990 Luzon earthquake or Baguio earthquake.
Okay.
When we talk about the Baguio earthquake or Luzon earthquake, people would remember the Haya Terrace that collapsed or
Yes.
that school that collapsed in Cabanatuan.
Yes.
But if you ask the question, which buildings were more? Buildings that collapsed or buildings that were left standing?
Standing.
Standing.
Yes.
That's the proof that we can build good houses and
Yes.
good buildings.
What intensity was
Intensity
that?
8 na yun.
Oh, intensity
It was
in Baguio.
intensity 8, yeah.
Okay, sir. A lot of people, now a lot of people are worried. Coming from this thing in Nepal, and now are forcing ourselves to look at our own situation here in the Philippines. How delicate is the situation in the country,
Well,
earthquake-wise?
the Philippines by itself is an earthquake-prone country.
Okay.
But the worry that all we have should be taken away by converting the worry to action. We worry because we think we're not prepared.
Yes.
And
Are
so
we prepared? Are we prepared?
Well, it depends on who you're asking.
Yes,
Okay?
sir.
So essentially, preparedness would mean that individually we know what to do during the earthquake. Structurally, our houses and buildings and infrastructure are earthquake resistant. After the earthquake, we know how to respond fastly, timely,
Yes.
and essentially recover as soon as possible. Telling people what to do during the earthquake and having them conduct drills would be much easier than making sure that their houses and buildings are okay.
Yes.
So when it comes to preparedness, the critical issue then would be how strong are our houses and our buildings. In a study that we conducted in Metro Manila way back in 2004 and re-evaluated in 2013,
Okay.
we found out that roughly 31 to 33,500 people will die if an earthquake would occur in the evening for the political Metro Manila.
Wow.
But remember, the reason why there is such a scenario is that there's a fault at the eastern section of Metro Manila called the West Valley Fault, part of the Valley Fault system, and this fault traverses from Bulacan down to Laguna.
Okay.
So essentially, the effect will not be in Metro Manila, but also the surrounding provinces,
Yes, yes.
Bulacan, Rizal, Cavite, and Laguna.
Yes. Yes.
And so the expected number of casualties might increase if we do not do anything.
Okay, this 33,500, 31 to 33,500 projected casualty. What intensity earthquake are we looking at
Okay.
for this to happen?
If there is a magnitude 7.2 earthquake, and that's what we call the maximum credible earthquake, we are not predicting that the next earthquake from this fault is 7.2. That's different. We are saying that this fault is capable of generating a magnitude 7.2 earthquake. If that happens, then the intensity of shaking in Manila will be high to low intensity 8, very severe shaking. Bulacan, big part of Bulacan, intensity 8. Some parts of Rizal, intensity 8. Some parts of Cavite and Laguna, intensity 8. And that is the typical intensity in the epicenter area. Like what happened in Bohol in 2013.
Yes, yes.
Like what happened in Negros in 2012.
Yes.
And essentially, if that is the case, then houses and buildings that are not designed properly will be affected at either slightly to heavily or even would collapse.
Yes. Alam mo, Director Solidum, if one just drives through the city, let's say drive on C5 or EDS or more on C5, it's very apparent that there are a lot of structures there, even to a layperson, that do not look structurally sound in case a magnitude 7 or intensity 7
We have to
or
be
8
careful about
earthquake
what.
hits.
What kind of structures are we talking about?
Let's say, private residences or
the
informal
the
settlers
informal
maybe,
yeah,
or
okay.
semi-informal
Yeah,
settlers.
okay.
Let's put it that
So,
way.
essentially, in the study that we conducted in 2004 and lately in 2013, we look at different types of structures. There are different ways to construct houses, but significantly in terms of the less than 10-story houses, there are significant percentages of houses that are called non-engineered buildings. These are buildings constructed by carpenters or masons without the benefit of supervision or consultation of licensed engineers, civil engineers, or architects.
No building permits.
No building permit.
Yes.
And of course, buildings are supposed to follow the National Building Code.
Yes.
So it all depends on how these were designed, whether the materials used were really standard, and whether the details of the construction were followed.
Yes.
So good design, good materials, and good workmanship will matter if there's an earthquake and whether the building will be okay or not.
So bottom line, follow the building code.
Follow the building
There it
code
is.
because our building code is good.
Yes.
A very good example again is what I said, the 1990 Luzon earthquake. Many
Yes,
buildings were
yes,
left standing,
yes.
and those followed the code not only in the design but in the details. Now, the real problem, not only in the Philippines but all over the world, would be people need to be educated of what would constitute an earthquake-resistant house or
Structure,
building.
yes, yes.
You add on the wind because you need to consider the horizontal or lateral forces of earthquake and the wind for either the stability of the house or the roof. No? But let's just focus on the earthquake. We should be aware that there are critical elements of construction that everyone should know so that when we build our own house, whether it's simple or very sophisticated, it will stand during a storm shaking.
Yes, yes.
We at FIVOX, together with the ASEP, Association of Structural Engineers of the Philippines, and JICA, developed two tools for engineers and ordinary people to understand what constitutes an earthquake-resistant house.
Okay.
We have developed a 12-point questionnaire, and for every question you answer 1 or 0. If the answer is positive, good for the building, you put 1. If not, 0. And example questions would be whether you used a minimum of 6 inches hollow blocks for the outer walls of buildings,
Yes.
whether you used a reinforcing bar of around 10 millimeters in diameter, whether the shape of your house is regular, it's not so fancy, like regular example would be rectangles or shapes, not letter L,
Oh, okay.
because this would matter in terms of the stability of
Interesting,
the house,
interesting.
whether you have a foundation, whether your house was built in 92 after or before.
Okay, what is it with 92?
92 was when the building code was better,
Okay.
was much improved.
Okay,
Yeah?
okay.
But doesn't mean that before 92 your house is bad, right? But,
No, because some people are saying that the older houses, the older buildings are actually better built
well,
than,
of
the,
course,
than the newer
it's
ones.
not simply the design,
Yes.
but the code provides you the design and material specification.
Yes.
At how you constructed it, of course, you can do it very well. No?
Director, this is this is an excellent tool, an excellent guide for people, for lay people even to assess whether their homes are earthquake resistant. Is this available online?
This
or
is
on your
available
website?
online, our website. Just Google FIVOX, or our website is www.fivox.dost.gov.ph. The second tool is more sophisticated.
Okay.
If the house owner and the local engineer will combine, we are distributing for free a software that would enable the house owner or the engineer to design their own house in the software and shake it.
Wow.
And see, well, of course, you don't see the physical shaking,
yes.
but the formula are there, such that at the end of the simulation, you would know if the house is okay or not for an earthquake.
Okay.
More sophisticated than the 12-point questionnaire.
And this is available as well to people who need it, who would like to request.
We are training civil engineers all over the country because you have to be trained on how to use the software. Okay? And why are we doing that? Because simply, there is a problem when it comes to earthquake. I use the analogy of diseases or sicknesses of people, people would go to the doctors to seek consultation. And for earthquakes, supposedly, houses should be built or supervised by engineers.
Yes.
People should talk to the engineers. But it's not like that.
Yes.
So, going back to the sickness, if there is a problem with people or several sectors of our society, if they cannot afford the consultation with the doctor, there are medical missions.
Yes.
When it comes to sicknesses of the building, maybe there are already engineering missions to evaluate this, but it's not.
Are there any? I mean,
yeah, there have been some,
yes.
but it's not a standard practice.
Mm.
And that would show that our public does not talk to a lot of professionals.
Yes.
So the professionals should reach out. The problem, though, is the reason why they're not reaching out is they don't know that they need to do that because simply they don't appreciate that there's a problem with their house.
Yes. Actually, sir, that's an excellent idea. Like an engineering mission, not a medical mission, but engineering
Like a
mission.
medical mission.
And probably you would save hundreds, thousands
Yes.
of lives. I said 33,000 is your.
And I have
projection.
another suggestion.
Yes.
After major disasters, there are so many people that would want to help others. Why not help them now before these buildings collapse?
Preventive maintenance.
Yes, just like
Announce
preventing your car to.
Announce a prevention is worth a pound of cure, no? More than a pound of
So
cure.
the first thing is have an audit of all houses and buildings, not only the mid-rise to tall buildings. Ordinary houses should be audited. Find out which are problematic. And the local government and the national government and the whole of society should look into how these people can be assisted. Financial incentive or tax break, whatever.
Yes.
Right?
Yes. Sir, unfortunately, this whole thing about earthquakes, it comes to our consciousness when we see it happening elsewhere, but then people kind of forget, and it gets placed in the back burner, and
That's why
that's the problem.
That's why we don't stop talking about earthquake only after there's a
Yes,
major
sir.
earthquake.
Yes.
But we do our work constantly.
Yes.
If we're not so busy attending to emergencies, we're actually very busy in doing earthquake scenarios, volcanic eruption scenarios, tsunami scenarios, producing hazard maps, and talking to various stakeholders on how to prepare for these events.
Yes, sir. Yes,
We're
sir.
very busy on that.
Yes, sir. Director Sildum, we have to pause for a break, but we have one more segment. So guys, don't go away because more of the science of earthquakes when Philippines Uncut returns.